Well, hello everyone. Let's go ahead and jump in, and we're going to be talking about production ML for mission critical applications. So let's get started. Let me see if I can get my slides to work. There we go. Okay, so we're going to start because we have kind of a mixture of people in the audience. Not everybody's an ML engineer or data scientist. We're going to start with the fundamentals of supervised machine learning, which is the most common form of machine learning. And to do that, we're going to train a model. And in fact, you are going to be the model. So we're going to train you. This is a gecko. Take a good look and try to remember what they look like. Maybe you already know about geckos, but maybe you don't. This is a chameleon. So they look a little different. Try to remember what the differences are and how they look. That's another gecko. And another chameleon. And another gecko. Another chameleon. Okay, so you've just been trained. Supervised learning is essentially learning by example. And so we've shown you a bunch of examples and told you what they were. So now that we have a trained model, we're going to try to use you to do predictions. It's also referred to as running inference. And usually I do this in front of a live audience, so I can hear what people are saying, but is that a gecko or chameleon? And how about that one? Is that a gecko or chameleon? And that one, gecko or chameleon? Okay. So if we were training a model with software, we would have measured how many right answers you got, and that would tell us how accurate you are as a model. But of course, I don't know how many right answers you got, so we'll just have to continue. And we'll start by looking at why is production ML different. Well, to start with, if you're doing machine learning in a research or an academic setting, maybe in school, then you're going to work on a project. You're going to collect some data and train a model, and then write a paper about your experience, probably, or maybe turn in an assignment. But if you're doing production ML, creating the first model and training it is just the beginning of the journey. What you need now, in order to use that model in a product or service or business application, is ML ops. So let's talk about why you need it. There's two big reasons: change and process. So let's talk first about change. We're going to use a little thought experiment to try to illustrate this. So imagine that you're a retailer and you're selling bicycles. And so you train a model using data from your app to help you order inventory. That tells you how much inventory you need to order, and that's forward-looking because you won't receive the inventory until some time later. And at first, things are going great because you've trained your model and it's gotten good accuracy. But suddenly, probably slowly at first, you start to see problems. You either order way too many bicycles or maybe the wrong types of bicycles. And that's not good for a business to start making mistakes like that. They're dedicating, in this case, they're dedicating money to inventory, and it's going to hurt their business. But why? Why did it suddenly stop doing well after it had been doing well before? And maybe more important, how do you even know that you have a problem? Well, unfortunately, the big thing there is that the world changes, and your data and model need to change too. So we can actually see that ourselves with you, the model that we just trained. Is this a gecko or a chameleon? So maybe you've moved and now you're working, our model are being used in a different country or something. This is an example of the kind of situation where it's difficult now because the data is so different from what you've been trained with. Something has changed. The other big reason for MLOps is process. So to do production machine learning, you need all the things that you need for any machine learning development. Usually that means labeled data, and then you need to make sure that it covers your feature space in the same way that your prediction request will. And you want to optimize things like minimizing dimensionality, maximizing the predictive data, making sure that you've considered fairness and responsible AI, rare conditions. So, for example, in autonomous vehicles, rare conditions can be extremely important. And what this really gets down to is the life cycle of your data and your model, including your model schema and your data schema. But along with that, because you're putting a piece of software into a production deployment, you need all of the things that any DevOps deployment needs. You need scalability. You want to make sure that things are extensible, that you've managed configuration. You want your results to be consistent and reproducible. Just basic software engineering like modularity and best practices. And testability is a little different for machine learning because you don't have just code, you also have a model and data that need to be testable. Monitoring is incredibly important, and safety and security for both your data and your model, and there's attacks that can happen against models. So at Google, we had exactly this problem. We needed something to do exactly this. So we're on our third generation of platform for this. It's called TFX, and it's used all over Google. It's used in a lot of Google products that you probably recognize. It's used in Google Cloud products as well. If you used YouTube or Google Meet, actually, you're using something that used TFX. It's also used in a lot of products from other companies, a lot that you've probably heard of, and maybe some that you haven't. But there's been over 10 million downloads of TFX. So a lot of people are using it. And it is an open source platform written in Python for the most part that you can use. This is looking at kind of a conceptual view. On the top are the tasks that need to be performed in training a model and serving the model. So it starts with ingesting the data set, and then you try to understand the data better and do some feature engineering to transform it so that it trains better. And then you need to really do some deep analysis of the performance of your model. And then if it's good, especially if it's better than what you already have, then you're going to push it into production. So that's on the top. In the middle are open source libraries that are available for each of the parts of this flow. And those are used by the TFX components in orange below. And really, those are just the components that you get when you do a pip install. I call this the hello world of TFX. So these are the standard components that just come out of a pip install. In orange, we have a training pipeline. In green, we have a inference pipeline. Getting a little bit of an echo. But the big thing here is that you're not limited to just these components. You will most likely write your own custom components, and there's different ways to do that. But it's fairly simple, and there's a lot of examples. To deploy your model, you have a choice of different deployment targets, including TensorFlow Serving, but also TensorFlow Lite if you're doing a mobile application, or TensorFlow JS if you're writing an application for a web browser. So let's take a look at what a component is mm, at a little deeper level. There's three main parts of a component: the driver, executor, and publisher. Really, you do when you create a custom component, almost always the work is going to be in creating the executor. The driver and publisher tend to be boilerplate. The driver is going to pull the input that the component needs, and the publisher is going to take the results of the component and push them back. So to do that, we use a metadata store, which also becomes a repository for all of the artifacts that are produced every time you run your pipeline. So a component will pull its input from the metadata store over an input channel. It'll do whatever it needs to do, and then it'll put its results back into metadata through an output channel. And the output and input channels are just classes that are their convenience classes. So that's how data flows through a pipeline. You have an upstream component that is going to do something. Of course, it begins with ingesting data into the pipeline, but it's going to do something, it's going to produce an output, and then components that depend on that output will start to run and they'll produce their output. So data flows through the pipeline that way. And the things that flow through are artifacts. And there's different kinds of artifacts. There's data sets, there's models, there's the metrics for a model, there's the statistics for your data set, and so forth. So the metadata store is kind of a core piece of this whole thing. And it's something that lives not just for a single pipeline run, but over the life of the deployment of TFX. So what is the metadata store? Well, it stores artifacts, and artifacts have types and properties, like trained models, for example, or one type of artifact. And they're grouped together, they're associated with each other in the sense of their execution run. So as you go through the pipeline, you're doing an execution run, and later on, when you need to recreate the artifacts that were produced, you can do that by querying the metadata store through the execution runs. And one of the things that allows you to do is establish data provenance or lineage, where you can trace back for a given artifact, what were the artifacts and operations that led to the creation of that artifact. And that's both important for understanding your pipeline and your code, but also it can be important for regulatory or legal purposes. To do a lot of this, we use a distributed processing pipeline because TFX is built to be able to scale to petabytes of data. So we use Apache Beam for that. And Apache Beam is an abstraction layer on top of native distributed pipelines like Apache Spark or Flink or SAMSA or Google Cloud Dataflow. It also includes a direct runner, so you can run everything just like on a single machine, like on your laptop. We use the Python SDK. So there's a number of different target deployment platforms that you can run on with Beam. And there's a number of different SDKs for different languages, and Beam sits in the middle of that. So using an SDK, you generate an operation, it's called a P transform, and give it some data, it's called a P collection. And Beam translates that into the native SDK or API for the platform that you're actually running on, and that produces a result. We're looking at that a little differently. From the point of view of a TFX component, the executor in the component is going to use the Beam SDK to create a Beam pipeline, which gets sent to some cluster somewhere. And really, from the point of view of the executor in the component, you don't really even know or need to know what the actual cluster is. That's going to create a result, which is going to get translated back into the abstractions of the SDK. So that's how processing of large amounts of data happens with TFX. TFX is very portable. One of the things that we say is that it runs just about anywhere. And that's really pretty important because you have teams that are spread all over the place in different situations. People may be, running on a shuttle or what have you. So being able to execute, for example, in a collab, you can run an entire TFX pipeline in a collab and not, load it on the system. You can run, of course, on your laptop, and run all of your code, and then when you deploy onto something like Kubernetes or Vertex, you're just gonna change maybe 1 or 2 lines of code. So for orchestration in a notebook, it's really just Python as you step through notebook cells. But you can also, especially for deployment, use something like Apache Airflow or Kubeflow for your actual production pipelines. And for processing, you can run, again, everything on a single system, using the Beam Direct Runner. But of course, you could deploy it out for large amounts of processing on distributed clusters like Spark or Flink or Dataflow. And TFX, although it does come from the TensorFlow team, trains more than just TensorFlow. It really, any Python-based modeling frameworks, and that includes scikit-learn and JAX and PyTorch and XGBoost, or even if you want to work in a different language that's not Python, you can train whatever you want in a container and have what's called a containerized component. So for orchestration in a notebook, this is really useful when you're doing development. You can run through the notebook and work on your code. And then when you're going to push it to production, you may change like 1 or 2 lines of code. So the standard components that we saw earlier, we'll go through those fairly quickly. There's the example gen that ingests data into the pipeline. It's going to use Beam to split that data and convert it into whatever dataset artifact format you're using, which currently is TF record and TF example. But as you can see, there's a number of different formats that you can use that you can ingest into a pipeline. One of the things it does is it'll split for training and evaluation. So in machine learning, you have to do splits like this so that you can test your model. It also splits it up into spans of data so that if you have large amounts of data, it comes in chunks instead of as one big lump. Statistics gen is used to analyze your data and record statistics like the standard deviation of each feature, or for categorical features, what are the valid categories? And it's got some nice visualization too. Transform is used to do feature engineering on your data. That's going to transform your data so that it helps your model learn better. And trainer is where you train your model. So that's where your modeling code will go. And it's also where you adjust hyperparameters. And we have a tuner as well for automatic hyperparameter tuning. And your model could be TensorFlow or really any Python-based or non-Python-based framework. For a non-Python-based, you're going to write your own container for that. There are advantages to using TensorFlow because some of the tooling is really designed, works better with TensorFlow, but you can make it work with whatever you need. Then there's Evaluator. Evaluator uses the TensorFlow model analysis library, and it does really deep analysis of the performance of your model, meaning that it's the performance on for slices of your data, not just the data set as a whole. So understanding things like different types of customers or different products in your business. this is how you analyze how your model performs on those different slices. But as I mentioned before, custom components are an important part of doing TFX development. So there's three types of custom components, and the easiest one by far is a Python function that you just add a decorator and some annotations. You can also create components using containers, and you can also, just a more Pythonic way, just extend existing component classes. When you build your own components, they plug into your pipeline exactly like any other component. There's no difference there. So for a Python function-based component, it has this decorator at the top, the add component decorator, and then there's some annotations on the arguments to the function, and then that's just a Python function. Container-based component, if you're familiar with Docker files, this will look very similar. It has a wrapper that you use to wrap the definition of the container. There's an image, which is going to be what you start with, and then you're going to add layers on top of that. There's similar arguments for the inputs and outputs, so similar annotations for that, and the command, just like a Docker file, to start up your container. So, let me go back. If you're interested in learning more about production ML, and this slide is not loading right for some reason. We created a 4-course series with Andrew Ng that is on Coursera, and it'll help you come up to speed, not just on TFX, but the whole range of technologies that are involved in production ML or MLOps. There's also the TFX add-ons community, which for some reason the slide isn't loading. But TFX is an open source project, and there's a community of well over 200 developers that are developing additional components and tools and libraries to add to TFX so that we don't have everyone reinventing the wheel. And there's our repo, and you can join the group, and we'd love to have you. And here's some links to get you started. But the easiest one is probably at the top there, just our webpage. And there's some stuff on YouTube and so forth. So, and that's my talk.
Robert, thank you very much. It was interesting to hear about production ML, and we do have some questions. So let's go right through them. So first one is from Ostap, and he's asking, how can one ensure data quality end to end through the pipeline? For example, add data quality tests, distribution tests, expected values, etc.
Yeah, so really that's, I don't know about through the pipeline, but at the beginning of the pipeline, when you're preparing your data, you need to often do what's called data wrangling, where you kind of clean up your data set and maybe fix things like if something was supposed to be an integer and some of the examples came in as floats, you try to fix things like that. One of the things that comes with TFX is something called example validator, which looks at the schema and the statistics and tries to look for problems with the data and then notify you. So you have tooling like that. You can also try to look at, as things change over time, for skew, data skew, and there's different kinds of data skew that you can try to detect. And you use TensorFlow data validation to do that. That's a good place to use a custom component, really. And you can, one of the things you can do is through a custom component, you can add alerting and, send a message to someone if the thing crashes, things like that. There's also an exit handler as well to check the exit status for the pipeline.
That's very useful. Are these examples also available in like tutorials, or how can people learn more about that?
About which?
About this like data validation. Is it like TensorFlow
Yeah,
X to. Mhm.
yeah. There's tutorials on the TFX website. There's a lot of tutorials. Um, and there's a lot of examples too in the TFX repo, in the examples folder, that can really, help you get started and dive into uh, some of the areas a little deeper.
Thank you, Robert. Like to all of our viewers, we also want to thank TensorFlow X website for promoting our conference. Thank you for your support. So our next question is from Diana, and she's asking, "What is the price of a mistake in a model in a mission critical product?"
What is the price of a mistake?
Yes.
Well, it depends on what the mistake is and how you are using the model. Um,
Do you
you
maybe have
know,
some
I
examples
mean,
of a fatal
yeah,
mistake where you lost a lot of money?
uh, so yeah, I'm trying to think of a bad mistake. I mean, one of the things that I've done in the past is try to predict Wi-Fi network operation. So when the model doesn't do that correctly, the Wi-Fi is not so great, and people tend to complain. So that's
Relatable,
that's
yes.
yeah. I mean, in the bicycle example that we just looked at, you'd end up with a situation where the business was uh, impacted
Mhm.
either with extra bicycles or not enough or whatever.
Okay. Okay, I understand. Thank you. Well, I have one more question from myself. So,
Yeah.
I think there is like a bit of a like distinguishing between the role of a like data scientist who is developing the model and then someone who like data engineer who is like working on model production. How do you think this role is going to be in the future? Do you think that like data scientists right now need to start learning how to put their models to production? Or do you think this would be like two separate roles going forward?
Hmm. There's actually three roles. There's data scientist, there's data engineer, and there's machine learning engineer.
Hmm.
Um, and the at least, and this is my opinion. There's no right answer here, but
Of course.
in my view, the machine learning engineer is the most useful of those three because they're someone who can both write production software and train an ML model well. So they can do both of those. Data scientists tend to be more focused on the statistical and mathematical side of machine learning and not so strong usually on the software engineering. So what I see is there's different teams at different businesses. It tends to become part of the culture of the business. Um, and sometimes you'll have a team that's strictly a data science team, and then they'll hand off their work to engineers who will handle deployment and putting it into production. There's issues with that because you always have this delay and you have to translate someone else's work.
Hmm.
But that's the way some teams like to work. A data engineer is really focused more on the infrastructure and the data itself as it flows through the system. So they're interested in like optimizing transformations and managing the infrastructure that's involved with that and so forth. Um, so did I answer the question?
Yeah, thank you. And it would be honestly really interesting for me to know if we do have any of people who have these roles in chat. So please, if you can, just message us in chat if you're a data engineer, a data scientist, or a machine learning engineer. It would be really nice to know our audience. But also, if you're a student who is learning and you maybe have some idea of what you want to do, please do tell us as well. We do see we have an analytics engineer here with us. Cool. Ostap was actually a host yesterday. So Nice to know. Okay. Okay. One more question from me. I think we have time for that. Is Do you use any of the do you use TensorFlow X inside of Google for developing your models, like internal
Yeah,
models?
yeah. Well, you mean me personally or Google? We well, the answer is both. So yes, TFX is used all over Google for. I think I had a slide on that. So things like YouTube, the YouTube team uses Google. Or they use excuse me, TFX. Um, Gmail team and so forth. It's yeah. And do I use it? Yeah, I do, but uh, mainly for things like developing examples and so forth. I don't have any mission critical uh, you know, products or services that I work on directly.
Mhm. Okay, interesting. We also have in chat Andrei, who told us he is a front end DAO who's slowly moving towards data science in free time. So, maybe what would you recommend to those developers who are not in data science but are looking forward to change their area of expertise?
Well, I did that. So I started out as a software engineer and worked for many years as just a pure software engineer and worked in web development and so forth. So if you develop an interest in something like that, and over the course of your career, you probably will do that several times. Go out, look for resources where you can learn about it, and then try to look for projects that you can work on. It's always good to have like an actual project where you're going to try to use what you've learned, um, and that's how you come up to speed. But there's an amazing wealth of material these days uh, for all kinds of things, but for machine learning especially, there is an incredible amount of material to learn how to really train models, understand data, understand the statistics, and the processing requirements. And there's a lot of areas of it. Things like responsible AI, for example, is a whole field by itself, um, which is for me what makes it fun. There's a lot a lot of different areas to learn about, and I love to do that.
I agree. I think like if you're working in IT right now, you have to be ready to learn something all the time, and I think it's part of what makes it cool. So, by the way, while we are talking about learning, there is a very cool program called Machine Learning Bootcamp, which is organized by Google developer groups, and I
Mhm.
think it's going to be a bootcamp from July to October, where people can apply and get access to free online education. And maybe if you are a developer or a student looking to learn more about machine learning, you can apply. The deadline is in 5 days. So you have 5 days to apply. The deadline is on June 20th. I think I will share the link in chat. This could be useful to some people. So if you're interested, let me know and I'll share more info to people interested to learn machine learning.
That sounds great.
And Robert, it was very nice speaking with you. Very interesting to hear about ML in production. And there are a lot of people enjoying the Geeko memes. So we even have a GIF in chat. If you want to talk more to Robert and ask about his experience, ask about maybe his talk, ask about MLOps or TensorFlow X, Robert is going to join our breakout room. So feel free to join in as well and talk to Robert directly. But for now, thank you so much for joining us, and we're really happy to have you here.
Thanks, my pleasure.